For many years, pkg.go.dev has been the central place to discover Go packages, also called Go modules. I really like this project. It has consistent design. You don't have to publish the packages explicitly, unlike in the NPM registry. The documentation is basically generated from the source code that's part of the Go module mirror. There are a few services from Google that help you download the Go modules. So there is a Go module mirror, there is an index database, and checksum database. So you've probably seen things like sum.golang.org, index.golang.org, and so forth. So as soon as your modules appear here, they also will be instantly available in the pkg.go.dev as a documentation. For example, I'm maintaining this PayPal SDK library for Go. That's my repository, and you see it's already here with all the documentation, with examples, with the symbols, types, functions. I never had to publish it, right? Because it's part of the Go module, it's distributed, and everything is available here. So every Go developer can go to this website and find some popular package. And recently, less than a month ago, the amazing Go team has published the API of pkg.go.dev, giving us the direct access to the functionalities of the pkg.go.dev website, meaning that we can search the packages, look at the symbols, vulnerabilities, and so forth. In the blog post that I will link in this video, we can find the list of endpoints that are available to us. So for example, get information about the package, about module, a list of versions, search packages, symbols, vulnerabilities. We can provide the package name nicely here. Also, they publish the open-API specification online, so there is a YAML file that will be useful for us later. And this could be very helpful because you see, I work mostly in the terminal in NeoVim, and I don't want to leave it when, let's say, I want to browse for some Go modules. So I could build some sort of TUI or terminal UI application that helps me search Go modules, Go packages, maybe see the versions, symbols, types, and so forth. So that's what we are going to do in this video. First, let's explore some of the responses of this API. So all the endpoints are GET endpoints, and they return some structured data. They're cache friendly, and they're usually fast to respond. So let's just call one. So it will package.go.dev, then the endpoint name, and then we provide the package name, which is usually starts like maybe github.com. Maybe I'll pick some of my packages. And I think you have to specify the version if it has one. So let's try that. And maybe pipe it to JQ. Cool, so that's the basic information about the package. The endpoint is v1 beta package, gives you the module path, the one that you define in your Go mod file, the version, and then some other information. So that's just the basic information. If you want to know more, we have to call other endpoints such as versions, symbols, and so forth. So what can our TUI application look like? I think it could be a terminal-based browser where we have a single input for the package name. We either can put the full name or partial name. It will give us the list of the results, and we can click into one and see the details and browse through the versions and symbols. So let's build that. We will obviously write everything in Go, and we'll have to call some APIs and parse the responses. And there are obviously multiple ways of doing that. We can create our own types in the package, call the API directly. But as I mentioned before, the team provided the open API specification via this file that's published at pkg.go.dev as well. So we can generate the Go types and actually a client as well using this specification. For that, we can use the project called oapi-codegen, about which I actually made a video a few months ago. It's a great project from Jamie Tanner that lets you create different servers or clients from the OpenAPI specification, either published somewhere online or via a file on your system. So let's install it and create everything we need pointing to the OpenAPI specification. So let's install the latest version first. Now we can use the oapi-codegen CLI to generate the types I specified and a client from the OpenAPI schema. And I also tell it to put it into the package site API folder. I like to keep types and clients for the API in a separate module, which matches this module name, and the file client.gen.go. So let's run that. Unfortunately, this command has failed. At the time of the recording of this video, the OpenAPI schema provided by the pkg.go.dev seems to be missing some fields like path and some types, which is unfortunate. I had to download it and put it locally and fix some errors. Now I can run the same command pointing to the local file as you see here. It's a little bit unfortunate that I have to do that, but I didn't find any other option. And this will indeed generate the client gen.go file, which we can see here and can use types from there, client and methods as well. There are a few other issues with this OpenAPI specification that I found. For example, there is a type called search result that I would love to use because that's the type that comes back when you search for modules. Unfortunately, as you can see, it's not used anywhere, so I had to define this type manually because otherwise oapi-codegen won't generate the type because it's not used anywhere. So I think Go team could do a little bit better and hopefully that will improve with time. So I'll be using the BubbleT framework to build all of that. I have a dedicated video explaining how to use BubbleT, how to use the Bubbles component library. So because we'll be using some components from here, we'll be using exactly text input and we'll be using the viewport that has some vertical scrolling. So these are two components that we will need. So let's just install everything. Let's init our local module with a name. Let's install BubbleT and Bubbles. The concept of BubbleT is very easy. There is a model and there is a view. Model keeps some application state and view represents that. And they can communicate through the messages. So that's very easy. And I prefer always to define the model first. So let's do that. Let's create the file model.go, where we'll define the model type and then maybe some other necessary types and functions. Actually, this file won't have the main function. It will have some types. So first of all, our application will have few focus modes because there will be a few sections. There will be an input, there will be the list of results and the details section. So let's define all these focus points as enum. In Go, we can do simply with maybe just enumeration, something like that. And now we can define few constants of this type. So let's do focus input of type focus mode. In Go, we can use iauto to basically define some enumeration that will follow the 0, 1, 2 sequence. And then what do we have? Focus results next, and then focus detail. So basically our application has 3 modes. Now we can define the model type or struct that will hold the state of our program. And our model will have quite a few items. So it will have the UI components, it will have our API client and the results, and some UI state. And let's start with some UI components. So we need input, which will be text input. Will it import correctly? Cool. Dot model. And then the same we'll do for viewport. So in viewport, we'll be showing the results of the package. So we'll do viewport exactly from Bubbles. All right, so viewport one more time, and then model as well. So we just have 2 UI components, nothing else. We have some state of the application, so maybe we'll have loading state. Of course, we will have a focus that we defined earlier, and we will also have the current item index because we will have the list of the results, and that could be just integer. Now our model will have few things from the API. So we obviously need to hold the client that's been already generated for us. So we can load it from package side API, I believe, dot. Is there a client with responses? I believe that. Now we need the list of the current results. Again, package side API search result that I mentioned I defined myself previously. We need the current selected item that could be a pointer to, again, package side API search result. And in this version, I'll be showing, for example, things like versions and symbols of a given package. So we can also define versions as, I believe it comes as a paginated response, something like, right, paginated response, and then symbols as well. I can also probably add the error message just in case something fails. And I think that's pretty much our model that contains the state of our application. As I mentioned before, BubbleT is based on the concept of messages. So we need to define the type for each message that we can receive from the view or maybe from other places that hold some information. So we'll have actually 3. We'll have the message for, let's say, search message. It's when we get the results back. we can type here as maybe items, and that would be similar as package site result, search result, right? We will have another message for detail when we get the detail back from the API, and that would contain probably the path to our module. It's basically the full path of the module, and then we'll have inside versions and symbols, and I believe I can just get it from here. And another type of message that usually all bubble tea programs have is the error message type, right? So we'll call it, maybe error MSG, which for now, for simplicity, we'll just have the text as a string. Now, as we are done with types, we can initialize our model with the initial data. So we can have the constructor function, like maybe new model, that receives the client. We will send it from somewhere else, right? So I guess that's the client. And that simply returns the model type. So first, let's define our input. I believe it's text input dot hopefully dot new. We can set few things on that input, like properties, probably placeholder. Is it a function or just a property? We'll see. Search go modules. We can focus on that input. So as soon as we launch the application, the input is in focus. We can set some default width as 50 cells. Then we can have the viewport as well. So let's do viewport. Is it also new? Okay, so we can obviously go for resizing functionality, but for now, for simplicity, we'll have it static. And that's it. Now we can return. Let's do model. Let's do. So then input. What else we have? We have viewport as VP. We have our focus. So initial focus will be focus on the input. And I believe that's it. So loading is false. All right, and then we forgot also to send a client, right? Now that's what we need for initial model. Models that we create have to satisfy the interface that Bubble Tea defines for the model, which actually is quite simple. It has the single init method or function that needs to return the t.command or cmd. So we also do on the model a function init. So exactly .model init without any parameters that needs to return t.cmd. And usually when you have an input, you can simply return the text input don't blink as the default init cmd. It doesn't have to call it, should be like that. Now let's start gluing everything. First of all, remember I defined these messages that have to be sent from somewhere. So I'll create the commands.go file where we'll have the functions to actually do the actual search and maybe get the details. So that will actually call the API. So let me create the file where I'll put everything. So commands.go. Fast forward, I define these two commands or functions that both return tcmd. We need to specify that it's a message, so that's why we are saying here t.message, and we are using our types that we defined before. So search message that has the items, and then detail message that has package details. Inside of these two methods, we actually call the Go API. So we use the client, we pass client to these commands, and we call, for example, get search with response. We pass the limit, so for simplicity I'll be using 10 here. We pass the query as well, right? So the search takes the query from the view. We will glue it everything together. For now, these functions are not used yet. And detail cmd does the same. It doesn't get the query, it has the actual current item selected in the result list. And it also calls the Go API to get the versions for the package, symbols for the package, and we can extend it later if you want to. You'll just need to pass more information into the detail message that comes to update function of Bubble Tea that I'll be implementing next. Now going back to our Bubble Tea model. There are actually three methods that we need to implement to satisfy the bubble tea model interface, which I forgot about. So it's not only init, it's init, update, and view. So the next one will be update. It's basically the update strategy for our model that reacts to different messages and events from view or from the system and actuates the state, so then we can render in the view method. But for now, let's just focus on the update. Now let's go slowly through that update function to make sure that we understand it properly. So it may receive different messages from different places in our application. So one message could be, for example, Windows size message, which we'll receive when our terminal window resizes. And in that case, we'll need to refresh the viewport. So very easy. Now there is a search message that I was implementing before when we get actually the search result. We update our model in this case. So you see, I'm passing the message items into the model results. And we're also resetting the current index to 0. We're focusing on the results. So we switch the focus from the input to the results, and then we do input blur. We refresh the viewport again. Now, when we get the detail message, meaning that we loaded some details, we are setting the versions and symbols that what we are interested about in terms of the details. We again refresh the viewport. Error message is simple. We simply display the error message. I mean, we will display it in the view, but for now we just set it into the state. What happens next is the handling of various key presses. For example, we are passing the keys into our input, and then also our viewport has some internal key bindings, for example, to scroll through that, to close that. And I also defined some internal key bindings. For example, Ctrl+C would be to exit our application. Tab would be to switch between focuses. So for example, if we are in the input and we click tab, we go to the results and vice versa. And then we can also exit the detail view if we press escape. So we switch the focus back to the results. And yes, when we are in the results with up and down, we can, or K and J as in Vim, we can go through the list of the results. We can press enter to enter the detail mode. So usually all of that is handled through our update function in the model, which sometimes can get complex, but also a good rule of thumb is not to have quite big models in bubble tea. I think still this is not the biggest. That's fine. It's easy to read. When we click enter, we obviously enter the detail. And when we are focused on the input and press enter, we actually do the call and call the search command. And that's it in terms of our update function. What's left is to define the view, which is quite simple. As you can see from the definition of this view method, it simply returns a string. So our goal here is to glue all the state together. I did it using the lines slice, and then I'll join it together, where we define kind of line by line what to render. Very important to know that we also inject the result of view method from the viewport and input, because they're also models, they also satisfy the same interface, and they have that view function that we have to call in order to basically display the input or display the viewport. And then we also handle the state, different parameters like loading, results, current item, and then refreshing the viewport. We basically show the details of that package inside of the viewport. Now, what's only left for us to be able to test all of that is to actually create the executable. So we'll create the executable. We have to, first of all, we have to create the client. So we'll have to client error, which I believe would be package site API dot new client with responses, I believe. And I think we need to pass the URL of our API, which for now is a constant, but may change with some time. So that was as we did before in this video, pkg.go.dev / I think v1 beta. I'm not sure about you, but I love the structured login slog package in Go. And then we can enable to create an API client. We can do error. And now we run our program. So I think it will be program error, probably, I think it's T new program. Then we need to pass our model. Remember, we created this constructor function where we pass the client. T program has some options or parameters that we can pass. one that I always use is, I think it's called Alt, yes, with Alt screen. So it kind of opens the alternative screen in the terminal and then exits when we exit. So it just like makes everything full size. Cool, so that's our main.go file, which glues everything together. Now it's time to run the program and see if it actually works. I will open the new tab and I think I'll just go run dot. Awesome, here's our view when we focused on the input. As you can see, the focus is default and we are ready to type our package. So I will do with my package that I can do it with before, without probably, that I maintain. And yeah, it actually found probably some forks. Yeah, because the description is the same, but that's mine. I can, yeah, maybe choose another one. What else do we have? We have tab to switch between focus or list view again. And when we click enter, it loads again and it shows the versions. It has the nice viewport with scrolling, which we can scroll with arrows, or J and K as well as a new Vim. For example, we could search for package UUID, that's widely used, and also see all the information about that. Now we can explore the Go modules not leaving the terminal, which could be a great productivity boost. You can check the source code for this program on my GitHub and extend it further if interested. Again, thanks Go team for exposing this API. I'm sure there are many nice tools and workflows that can come from that. Thanks for watching. Bye.